Hi everyone, welcome to Potato Chemistry. In this video, we will discuss the reactions involving metals. We will also look at a list of metal elements known as the reactivity series of metals. In this video, we will first talk about how reactivity can be defined, what is the reactivity series of metals, and finally, for the rest of the video, we'll look at 4 categories of reactions involving metals. Firstly, the reaction of metals with oxygen, water and acid, and finally, the reaction of metals with other metals. How do we define reactivity? There is no one universal definition on what reactivity is or how to measure it. However, there are general agreements on qualities that can serve as proxies for reactivity. For example, reactivity can be measured in terms of the rate of reaction, which is a measure of how quickly a reaction is occurring. In the same reaction, a more reactive element will have a higher rate of reaction than a less reactive element. One way to measure the rate of reaction is to measure how quickly products are released from the reaction. For example, if we add the same number of atoms of potassium and lithium to water, potassium would liberate hydrogen gas more rapidly than lithium will. Therefore, we can say that potassium is more reactive than lithium. Conversely, we can also measure the rate of a chemical reaction by measuring how quickly the reactants are used up. For example, if the same number of atoms of potassium and lithium are added to water, we will see potassium disappearing more quickly than lithium will. And this is because potassium is more reactive than lithium. Potassium gets used up more quickly, and that is why it produces hydrogen gas more rapidly. Reactivity can also be measured in terms of the ability of an element to displace another element from their compounds. Let's call this the displacement ability. For example, a highly reactive element such as potassium can displace many elements from their compounds, whereas an unreactive element such as gold can displace virtually no other element from their compounds. And this is the type of reaction that we're going to explore in a lot more detail when we discuss the reaction of metals with other metals. In a branch of chemistry known as electrochemistry, reactivity is usually defined in terms of reduction potential, which is related to the ability of an atom or a molecule to attract electrons from other atoms. However, this is out of the scope of this introductory video. By measuring the reactivities of different metals, scientists can rank them from most reactive to least reactive in a list known as the reactivity series of metals. A simplified version of such list is shown here. You may notice the inclusion of carbon and hydrogen in this series, although they are nonmetals. This is because many important reactions involving metals will also involve either carbon or hydrogen or their compounds. For example, the reactivity of a metal relative to carbon will determine whether it is extracted from its ore by reduction with carbon or by electrolysis. Metals more reactive than carbon cannot be reduced by carbon and are therefore extracted by electrolysis. Metals less reactive than carbon are extracted, usually by reducing them with carbon. As for hydrogen, the reactivity of a metal relative to hydrogen will determine how vigorously does it react with water and with acids. Metals that are less reactive than hydrogen, they typically do not react significantly with cold water or with dilute acids. Metals more reactive than hydrogen can react with cold water and dilute acid, and the more reactive they are, the more vigorous the reaction. Onto the focus of this video, the reaction of metals. The first reaction that we're going to discuss is the reaction of metals with oxygen. Metals react with oxygen to produce metal oxide. And these reactions are always exothermic, which means it releases heat into the surroundings. And the more reactive the metal is, the more exothermic the reaction will be. One example of such reaction would be the reaction of magnesium metal with oxygen. They react to produce magnesium oxide, MgO. This reaction releases a very bright flash of white light, which was once used as camera flash. The next reaction that we're going to discuss is the reaction of metals with water. Metals react with water to form metal hydroxide and hydrogen gas. And as highlighted in the reactivity series of metals, only metals more reactive than hydrogen will react with cold water. And this is because to displace hydrogen from water, the metal needs to reduce the hydrogen atoms, which can only happen if the metal is more reactive. An example of a metal more reactive than hydrogen is calcium. Calcium metal reacts with water to produce calcium hydroxide, also known as lime water, and releases hydrogen gas. Silver, on the other hand, is less reactive than hydrogen, so it will not react significantly when added to cold water. Next, the reaction of metals with acid. The reaction of metals with acid is similar to reactions with water in that they can only occur if the metal is more reactive than hydrogen. Metals react with acid to form salt and hydrogen gas. For example, sodium metal, which is more reactive than hydrogen, can react with dilute hydrochloric acid to form sodium chloride, commonly known as table salt, and releases hydrogen gas. Silver, on the other hand, being less reactive than hydrogen, do not react with dilute hydrochloric acid, so adding it to acid will result in no significant reaction. In addition to water, oxygen, and acid, metals can also react with other metals in the form of their compounds. In this video, we will discuss this type of reaction in two categories. The reactions of metals with metal compounds in the form of aqueous salt solution, and also the reaction of metals with metal compounds in the form of solid metal oxide.
In both types of reaction, the more reactive metal will displace the less reactive metal from the compound of the less reactive metal. The less reactive metal will then be displaced as a pure element, whereas the more reactive metal will become the new compound.
For example, when we're dealing with aqueous salt solution, when zinc metal is added to a solution of copper sulfate, note that copper sulfate is a metal solution containing copper, which is a metal less reactive than zinc. Therefore, zinc will displace copper from copper sulfate to yield copper metal, whereas zinc will now take the place of copper in the compound. It will become zinc sulfate. Just a note here, AQ means when something is dissolved in water. Similarly, when we're talking about reactions involving solid metal oxides, the more reactive metal will displace a less reactive metal from a metal oxide of the less reactive metal. For example, if we look at the reactivity series of metals, we'll realize that carbon is more reactive than iron. And that is why when we want to extract iron from iron ore, which is primarily iron oxide, we react it with carbon. Carbon being more reactive displaces iron from iron oxide, so iron is displaced as the pure metal. This reaction is highly exothermic, so iron will be extracted as molten iron, whereas carbon will take the place of iron in its oxide, so it will become carbon dioxide. This is not a balanced equation. Aluminium is more reactive than carbon, so aluminium cannot be extracted from aluminium oxide from a similar reaction. And this is why aluminium industrially is extracted by electrolysis. Another application of reactions involving solid metal oxides is a reaction known as thermite reaction. The most well-known combination of reactants to make a thermite reaction is the combination of aluminium and iron oxide. Aluminium being more reactive than iron will displace iron as iron metal, and this reaction is so exothermic that iron is displaced as a liquid, as molten iron, and aluminium will become aluminium oxide. And this molten iron that is displaced can be used in a type of welding reaction known as thermite welding. I hope this video has helped you understand the reaction of metals better. Thank you very much for watching.